Hello everyone! Today we are talking about free-falling bodies. Free-falling bodies, an object in motion, is characterized by a changing position as a function of time. The derivative of the distant function with respect to the time gives us the velocity of the object as a function of time. Furthermore, the derivative of the velocity function gives us the acceleration of the object as a function of time. But what causes an object to move? To understand particle dynamics, we need to first understand the concept of force. Newton's first law of motion states that an object in motion will remain in motion until acted on by a force. This observation is one of the most important one ever made, as it offers a way of defining what a force is. According to this law, an object traveling in space at 100,000 km/h will remain at the velocity forever provided no force action. For example, if you were to throw a ball in space, it would forever continue in the same direction along with the same velocity with which it left your hand. Here, space refers to anywhere that is free from the influence of any gravitational force, electromagnetic force, air resistance, or any other force. Once set in motion, an object will continue with the same velocity forever. Since no force is required to keep an object in motion, then a force can be defined as that which changes the velocity of the object. Force is a measure of resistance to a change in motion. Since motion is characterized by a constant velocity, then a change in motion results in a change in velocity. By definition, a change in velocity is an acceleration. This simple yet profound conclusion tells us the forces are defined by accelerations. The force required to accelerate an object is proportional to the magnitude of acceleration. The mass of the object is also a factor, since the greater the mass, the greater is resistance to motion. Observation shows that the resistance to a change in motion is directly dependent on the amount of matter being accelerated. Free-falling bodies that consider an object that is under free-falling motion. Recall that the body moves down because of its own weight or gravitational force. In addition, we will now consider an air-resistant force counteracting the free fall. There are many ways to assume it, but for now it's proportional to velocity. Free fall with air resistance, an object performing a free fall subject to a constant gravitational force in a viscous fluid is shown by a drag which is proportional to its velocity. Find general expression for this velocity of such an object. Free-falling bodies that consider an object that is under free-falling motion. Recall that the body moves down because of its own weight or gravitational force. In addition, we will now consider an air-resistant force counteracting the free fall. There are many ways to assume it, but for now it is proportional to velocity. Free fall with air resistance, an object performing a free fall subject to a constant gravitational force in a viscous fluid is slowed by a drag which is proportional to its velocity. Find a general expression for the velocity of such an object. Falling bodies. Falling bodies construct a mathematician model of the motion of a body moving in a force field. One often starts with the laws of motion formulated by the English mathematician Isaac Newton, 1643 to 1727. Recall from the elementary physics, Newton's first law of motion states that a body either will remain at rest or will continue to move with a constant velocity unless acted on by an external force. In each case, this is equivalent to saying that when the sum of the forces F equals to Fk, that is the net or resultant force acting on the body is zero, then the acceleration of the body is zero. Newton's second law of motion indicates that When the net force acting on the body is not zero, then the net force is proportional to its acceleration, or more precisely, F equals ma, where m is the mass of the body. Now, suppose a rock tows upward from the roof of a building as illustrated. What is the position st of the rock relative to the ground at time t? The acceleration of the rock, the second derivative ds over dt, if we assume that the upward direction is positive and that no force acts on the rock other than the force of gravity, then the Newton's second law gives. Falling bodies and air resistance. Before the famous experiment by the Italian mathematician and physicist Galileo Galilei, 1564 to 1642, from the Leaning Tower of Pisa, it was generally believed that the heavier objects in free fall, such as a cannonball, fell with a greater acceleration than lighter objects, such as a feather. Obviously, a cannonball and a feather, when dropped simultaneously from the same height, do fall at different rates, but it's not because a cannonball heavier. The difference in rates is due to air resistance. The resistive force of air was ignored in the model given. Under some circumstances, as a falling body of mass m, such as a feather with low density and irregular shape, encounter air resistance proportional to its instantaneous velocity v. If we take in this circumstance the positive direction to be oriented downward, then the net force acting on the mass is given by F equals to F1 plus F2 equals mg negative kb, where the weight F1 equals mg of the body is force acting in the positive direction and air resistance F2 equals to negative kb is a force called viscous damping, acting in the opposite or upward direction. See figure. Now, since v is related to acceleration, a by a equals dv over dt, Newton's second law becomes m equals ma m dv over dt. By equating the net force to this form of Newton's second law, we obtain a first-order differential equation for the velocity vt of the body at the time t. Example: a ball with mass 0.1 kg is thrown upward with an initial velocity 20 meter per second from the roof of building 25 meter high. What is the maximum height above the ground that the ball reaches? Solution: m over dt equals mg, dv over dt, dt equals g dt, v times t equals gt plus c, g equals to 9.8, using 0 equals negative 20, 9.8 times 0 plus c equals negative 20, c equals to 20, thus vt 9.8 t negative 20. To find st, we integrate vt, st equals to v times t dt, s times st equals 9.8t minus 20 dt equals to 9.8 t over 2 minus 20t plus d equals to 4.9 minus 20t plus d, using 0 equals 0. 0 equals to 4.9 times 0 minus 20 times 0 plus d. d equals to 0, thus t equals to 4.9 minus 20t. Set vt equals 0, 9.8 minus 20 equals 0. t equals to 2.018, then sub t equals 2.018 into st. s equals to 2.0418 equals 4.9. 2.018 minus 20 times 2.0418, s equals to 2.018 equals to 20.41. The height is equal to 25 plus 20.41 equals 45.41. the maximum height is equals to 45.41. And that's all. Thank you very much.